We might not notice, but tremendous technology and mind-boggling science constantly surround us in the products we use every day. Behind their practical use lurk hidden histories, dramatic discoveries, and awesome experiments. They are wicked inventions. Coming up, fire engines, from 4 horses to 700 horsepower, the fire-stopping science behind the fire engine. The vacuum cleaner, what role did the puffing billy and a pillowcase have in the development of our favourite dustbuster? The Jukebox. We find out the CD secret behind this iconic sound system's name. We reveal the surprising science and amazing manufacture behind these wicked inventions. Fire trucks allow firefighters to perform and complete their jobs quicker and more efficiently than ever before. But just how were they introduced?
In Europe, we used to have things called bucket brigades, which was literally teams of men with buckets. Problem was that by the time they ever got to a fire, usually the building had been lost. There's lots of accounts of bucket brigades literally exhausted by the time they get to fires.
This meant we saw the introduction of the paid and trained firefighters, which saw many sign up to the service to help those in danger. Horses then started being used to pull the newly invented pumps, meaning the response time of fire brigades was often quicker, providing greater efficiency on arrival.
And it was through the 18th into the 19th century that you had further developments, and you started to have steam-driven fire engines. But again, what was interesting is this, the steam part of the engine was provided to pump the water to a fire, but not drive the actual machinery. So it was still horse-drawn, or it was still pushed.
From this, we saw the introduction of the motorised fire truck, which became more common by the early 1900s. In the 1930s, fire companies started installing ladders on the trucks because of the increasing height of new buildings and structures. The longer ladders actually rose to 150 feet, which is well over 45 metres. The modern-day fire truck was defined towards the 1960s. The trucks were now made with more than just one water pump, increasing the chances of extinguishing the fire.
Early fire engines, of course, used bells, and this was a very common thing. Even from the very, very early fire engines, they would have had a bell to warn and tell people they were on the way. Now, of course, we have the very familiar sirens, so you know when a fire engine is on the way.
Nowadays, there's lots of different types of tenders. We have fire trucks which can go off-road, fire trucks which are purposely built for the airport, fire trucks which have ladders with pumps, all designed for specific reasons.
Today, fire trucks and fire brigades operate all year round, helping those in a variety of different situations. But just how are they made? The Panther fire engine is a powerful weapon to have when fighting fires. Commonly found in airports and areas that can be hard to reach, this machine can haul over 20 tons of firefighting equipment across large areas and rough terrain with ease.
Rosenbauer is an international company based in Austria doing firefighting equipment over 150 years right now. We are not only producing firefighting trucks, but also tools for the use of the firefighters.
The chassis is made from steel, which is bent and welded into different shapes. This provides a foundation for the mounting and fitting of all equipment, such as the electrical wiring loom and brake lines. The wiring loom provides power and data to every electrical element of the vehicle, whilst the brake lines transfer pressurised air to all 8 of the Panther's wheels. The engine is manufactured at a separate company and shipped to the Panther production line. Here, additional units, such as the torque converter, are added. When complete, this will develop a mind-boggling 700 horsepower. The completed engine is then hooked up to a strong crane that can support several tons. This crane carries the engine over to the chassis and lowers it into the engine bay with high levels of precision. Any incorrect moves could result in the engine swinging into the chassis and damaging some vital components. Once contact has been made, bolts are inserted and made finger tight. The crane can then be detached and the bolts made secure. The empty chassis can then be fitted with a temporary cab and driven into the next workshop. Here it is lined up over 2 long metal plates and the parking brake is applied. It's important the chassis doesn't move now because the metal plates lift into the air. This gives the mechanics easy access below the chassis as well as above. The engine's cover is removed as this is the main assembly line, where it will receive its protective bodywork. Next, the individual modules that make up the fire engine are added. First is the pump unit, which is hoisted into place on a crane. This contains most of the parts of the powerful water pump, which can take in 9,000 litres per minute. A few more parts are added once the module is attached and the pump is connected to the engine for a direct line of power. The second module to be attached is the large main tank. This holds 12,500 litres of water and 1,500 litres of foam. Plenty of extinguishing material then. A crane carries this in and slowly lowers it onto the chassis, whilst mechanics attach all the hoses and electrical cables to the pump module.
The third step is then to bring on the engine compartment, which is not only a cover for the engine, but also some space for tools and equipment for the firefighters.
On its own assembly line, an empty cab begins construction. This must be fitted with all the computers and electronics that govern features throughout the fire engine, as well as all the control surfaces to operate the high-power water cannons mounted on the front bumper and roof. Most of these controls are attached to the complex dashboard that spans the width of the spacious cab. The steering wheel is the same that you would find on a normal road car, but it has no gear stick as it is a full automatic vehicle. Instead, there is a large computer screen providing live information such as the amount of fire extinguishing agent remaining, as well as 2 joysticks, 1 per water cannon. The drivers must be very well trained as they often need to operate the steering wheel and the joysticks at the same time. Next, the roof-mounted water cannon must be fitted. A crane lifts the cannon into place and a mechanic secures it to the roof.
The roof turret is capable of discharging 9,000 liters water per minute with a throw range of over 100 meters.
The cannon is more than just a directional tube, as it has many valves and flaps that can be adjusted to change the flow of water coming out. This means one cannon can create both a wide wash and narrow jet of water to extinguish fires of different sizes. To allow for these controls, these electronics are also connected to the vehicle.
On the last station, the electrical commissioning of the Panther is done, which means that all the displays are configured, the modules are configured in the system, and a last electric check is done.
This means each component of the fire engine can recognize and communicate with each other, helping to create an efficient environment for the firefighters.
After the main production line, every Panther has to fulfill a quality check. This quality check contains of a driving part and a check of the pump system. Things like the discharge rate, throw ranges are tested for every Panther.
The fire engine is now ready to fight fires around the world. The Panther fire engine. Truly a wicked invention. With the American market alone worth over $1 billion a year, it seems a vacuum cleaner is still a domestic essential. Coming up, we'll find out if a vacuum cleaner actually uses a vacuum. But first, how was the vacuum cleaner actually invented? It's not an obvious connection, but it all starts with one man's quest to improve his wife's broom.
In the 1700s, Levi Dickinson noticed that his wife's broom wasn't working well. It wasn't actually brushing, the bristles fell apart, and effectively it wasn't a very good means of sweeping up dust and keeping the house clean. He, as an inventor and a farmer, he invented a much better version of that and sold that on, and actually started to sell brooms instead of pretty much everything else. This invention of the broom doesn't seem very linked with the vacuum cleaner, but bear in mind, in order for a vacuum cleaner to work, you need to sweep up or agitate something so that the vacuum can suck the dust out of the air, rather than sucking it directly from the carpet.
Many inventors realized some kind of air power could be useful to blow or suck the dust particles. But how do you power it? The big breakthrough came in 1898, when US inventor John Thurman submitted a patent for a gasoline-powered cleaner that blew dust into a receptacle. Although his machine was never a success, it did inspire British engineer Hubert Cecil Booth to create a true vacuum cleaner in 1901. His machine used a petrol engine to drive a piston pump that drew air through a cloth filter.
He essentially reverse engineered the patent of the American and worked out how to use it to suck dust. His vacuum system was a much more efficient system because you were no longer blowing dust anywhere, you were pulling it up and taking it from wherever it was and keeping it within a receptacle.
It was actually so big it was nicknamed the Puffing Billy, but it was actually used quite a lot, and actually it was commissioned to be used on cleaning Westminster Abbey for the coronation of Edward VII, so it actually was effective to some degree.
The widespread introduction of electricity to our homes would lead to the miniaturization of Booth's design. An electrical motor could be smaller than Booth's gasoline-powered Puffing Billy, and it could run off the sockets that were springing up all over early 20th century homes. All that was needed was for someone to come up with a new, smaller design. That someone was an American janitor named James Spangler. His tinkering in 1907 would eventually lead to the creation of the portable vacuum cleaner we know and love today.
He got together a brush and an electric fan and even his wife's pillowcase and created the beginnings of a vacuum cleaner. However, Spangler didn't have the money to invest in actually taking it any further, and he sold the patent to his vacuum cleaner to his cousin's husband, who was William Hoover. And actually this is where Hoover began.
The Hoover vacuum cleaner really exploded into the public consciousness during the post-war period boom of the 1940s and 50s, when America saw a 12-fold increase in the domestic appliance market. This popularity led to the name Hoover becoming synonymous with the vacuum cleaner, with many people referring to a vacuum cleaner as a Hoover, even if it wasn't made by them. The Hoover undoubtedly took the world by storm, but how did this revolution in domestic cleaning actually work?
A rotating brush agitates the dust or dirt and gets it into the air. Then a vacuum, which is a current of air, can draw it along, and that dust is then poured into a system. If it's a bag that's porous, the dust goes in but can't escape through the holes, whereas the air can. This captures the dust, which means that as the vacuum works, you continue to collect dust, but you do not continue to put it throughout the rest of the house or the building. Then the bag is emptied and put back, and you have a reusable vacuum.
Apart from looks and small details apart, the conventional vacuum cleaner changed little until James Dyson's Cyclone device took the world by storm when it was introduced in 1993. Unlike a conventional vacuum cleaner, the Cyclone vacuum cleaner uses cyclonic separation to remove dust and other particles from the airstream. Dirty air enters a conical container called a cyclone, where it is made to flow in a tight spiral. Centrifugal force throws the particles out of the airflow onto the wall of the container, from which they can then fall into a bin. Bag or bagless, both systems make cleaning your house a far easier chore than it used to be. But is a vacuum cleaner actually using a vacuum?
A vacuum cleaner does not operate under a true vacuum, as in the vacuum of space. A vacuum cleaner operates under the principle that if there's a flow of air from one end, you create a suction. So you're essentially making a current of air that is of reduced pressure, because air flowing has a reduced pressure. This reduced pressure draws air in from the outside and through into the current of air. You could argue that because the air is low pressure, what is actually happening is the rest of the air in the building is pushing the dust into the cleaner, which filters the air and allows the air to come out in a clean fashion into the main air. So your moving of the current of air, which is at lower pressure, is the vacuum we were talking about. But it is nowhere near what a scientist would call a complete vacuum.
So, a vacuum cleaner may not actually use a real vacuum, but it is truly a wicked invention. Can we suck up water by just using a candle? We're going to need a plate, a clear glass container, water mixed with food colouring, a lighter and a candle. To begin, we light the candle and place it in the middle of the plate. Then we place the clear glass container on top and pour the water on the side of the plate. After a few minutes, the water starts to be sucked up into the glass as if by magic. Two actions contribute to this effect. Firstly, covered by the glass, the candle's flame rapidly uses up all the oxygen inside the container. However, there are still other gases remaining inside the glass, such as nitrogen, argon, carbon dioxide, and others. These gases have lower pressure inside the glass when compared to the higher atmospheric pressure on the outside of the glass, and this higher atmospheric pressure from the outside pushes the water from the plate up and into the glass. The second action is caused by the candle heating the air inside of the glass. As it is heated, the air expands and escapes from underneath the glass. When the flame dies, the air inside the glass cools and contracts, which in turn pulls more water into the glass. Can we suck up water by just using a candle? Yes, we can. Wicked challenge smashed. The jukebox was an essential in almost any club, bar or cafe during most of the 20th century. But just how was this musical device introduced?
So the history and development of the jukebox really goes back quite far. It goes back to the time when you'd get music boxes which were operated by kind of metal drums and perforated paper parchments, which would then drive mechanisms with other instruments built in. So you'd actually have these big wooden boxes which, when you put a coin in or was activated by a crank handle, would then cause the instruments contained within the machine to play a popular tune. The term jukebox comes from an African-American expression for juke joint, and a juke joint was a house of kind of ill repute, quite a wicked, crazy place. So imagine these communities like in the Deep South where blues music and kind of swing and jazz was coming out. This is where the word comes from, jukebox, juke joint.
In 1928, the audiophone machine was created. This machine consisted of 8 separate turntables, which were individually mounted on a rotating Ferris wheel, allowing 1 record per turntable. Some of the earlier jukeboxes were equipped with listening tubes. These tubes were the first types of headphones and were commonly used by customers. Despite the constant use of the jukebox, there was little increase in the actual production of the device. This was due to their components, such as metal and plastic, primarily being used in the war effort. At the height of its popularity in the mid-1950s, approximately 750,000 jukeboxes were in use across the United States.
Companies started to realise that they could make these things look slightly more impressive and fancy, so you start to see music counters, so it would tell the owners of these boxes how many times certain records would be played. So you start to see that interchange and a rise of chart music as well.
With the advancements and improvements in portable music devices and speakers, we have seen the decrease in the use of jukeboxes over time. However, Sound Leisure in Leeds, England, are one of only 2 companies in the world that still make their classic jukeboxes today. But just how are they made? Sound Leisure Limited, based in Leeds, England, have almost 40 years of experience in building jukeboxes.
Sound Leisure was started in 1978 by my father, Alan Black, and it was originally established to service and repair jukeboxes manufactured by other companies. We saw a gap in the market to start reproducing nostalgia-style jukeboxes, originally for commercial establishments, so bars and pubs, and that took off, and over later years we've sold them mainly to people's houses and to properties.
But how exactly do they manage to build these nostalgia-filled musical machines? It all begins with research and design, where the team meticulously design their jukeboxes to the finest detail in order to create a box that feels and plays just like the original jukeboxes of yesteryear. Once happy with their designs, the manufacturing process can begin. Of course, our jukebox needs its box. For this, we begin at the workshop. For the particular model being built today, a replica of 1950s style rocket jukeboxes, a CNC machine is used to precisely cut the wood in the most accurate way possible. The wood can also be hand-carved and shaped by expert woodworkers, depending on the jukebox model being produced.
A great deal of our product is hand-built. People want to buy something that they know is unique to them, that they know is exclusive to them, and that there's nothing else that's out there that's exactly the same.
Once all of the wooden pieces have been cut and shaped, they are glued and fixed together by hand until we have our finished jukebox cabinet. This cabinet can then be decorated in a whole number of ways, from a traditional stained wood look, like we can see here, to many different colour options and designs, depending on customer specifications. Whilst the cabinet is being sprayed, the chrome fittings of the jukebox are prepared by metal workers who smooth and polish chrome parts that will go on to give the jukebox a fantastic finish. With our cabinet complete, the next step is preparing all of the sub-assembly pieces of the box. The relevant parts for each customer order have been handily organised into kit parts that are then fitted to the box. Here, a speaker board is being built, along with the addition of all of the decorative pieces that will give the finished jukebox its unmistakable, authentic look. This board is then wired by hand at the wiring station before being fitted to the cabinet. All other wiring for the jukebox is also completed here, like these buttons that are being wired and soldered, ready to be fitted and connected. All of the vital electronics that will make our jukebox come to life are also built on site, including the vital electronic amplifier. These can then be connected to the pre-assembled buttons and speakers, creating a seamlessly working jukebox. The jukebox is missing something vital though, the record selection mechanism. This mechanism is incredibly complex. It is built from scratch from many different parts that all need to fit together perfectly in order for the jukebox to be able to accurately select the correct record and then of course play it without any distortions. This takes great skill and many years of training.
When you're making a vinyl mechanism, we've got hundreds and hundreds of little tiny components that need to go together in a certain way so that it works and it will last the time that it needs to, playing every day. Those sort of skills are quite hard to attain, and we rely on the longer serving members of staff to train the younger members of staff, so we've got that sort of continued development of skill set.
These parts stay very true to the original mechanisms of the past, with just a few modern improvements. Once the mechanism is complete, it is carefully placed into the jukebox cabinet and linked up with the buttons, speakers and other electrical gizmos and is ready to play. Just look at that, a real blast from the past.
Once the jukebox is complete, it'll go to our final test facility where it's put onto test for a minimum of 3 days, just to make sure that it can be played non-stop without any problems or hiccups.
If everything works seamlessly after testing, the jukebox can be delivered to its lucky new owner.
The biggest reward is seeing the final boxes. They're great, and the feedback we get from our customers is always amazing. Our customers vary from just average guys who walk in off the street who've saved up for a long time and always wanted one, up to pop stars and sports personalities and some pretty famous people as well, but we're not allowed to name them, I'm afraid.
Jukeboxes, a timeless, wicked invention. So, there you have it, a dash through the hidden history, super science and amazing manufacture of products that you use every day, but have never realised their amazing backgrounds. Fire engine, vacuum cleaner and the jukebox, all wicked inventions.